Today, we're covering the most critical network ports every cybersecurity professional needs to understand. These ports are common entry points attackers scan first, and knowing their risks helps us defend systems more effectively. On this slide, we're focusing on remote access ports, what I like to call the front doors of a system. These ports allow administrators and users to remotely connect to and control a machine. Common examples include SSH on port 22, RDP on port 3389, VNC on port 5900, FTP on port 21. While these services are critical for system management, they also introduce significant risk if not properly secured. Because these ports are often exposed to the internet, they become the #1 target for attackers, especially brute force attacks. A brute force attack is when an attacker repeatedly tries different username and password combinations until they gain access. The visual here shows a hacker attempting to access multiple doors. Each door represents a service running on a specific port. The key takeaway is this: if even one of these doors is left weak or unprotected, it can give an attacker full access to the system. That's why securing remote access is critical. This includes using strong passwords, enabling multi-factor authentication, limiting access with firewalls or VPNs, disabling unused services. In cybersecurity, we don't just lock the front door. We reinforce it, monitor it, and limit who even knows it exists. 1. Introduction to port 21. To start, let's look at port 21, which is the default port for the File Transfer Protocol, FTP. FTP is one of the oldest protocols still in use today, designed specifically for the transfer of files between a client and a server over a network. 2. The concept of control versus data. It is important to distinguish that port 21 is known as the control plane or control connection. When a client connects to a server on port 21, it isn't actually sending the file yet. Instead, this port is used to send commands like login, list files, or download, and to receive the server's responses. The actual file data is typically transferred over a separate connection, traditionally using port 20. 3. Active versus passive modes. How port 21 interacts with data ports depends on the mode being used. In active mode, the client connects from a random port to the server's port 21 for commands. The server then initiates a connection back to the client for data. In passive mode, this is more common today because it's firewall friendly. The client still uses port 21 for commands, but then the client initiates the data connection to a random high port provided by the server. 4. Security considerations. From a security standpoint, standard FTP on port 21 is insecure. Because FTP sends data, including usernames and passwords, in clear text, anyone sniffing the network can easily intercept credentials. In modern enterprise environments, we generally prefer SFTP, which uses SSH on port 22, or FTPS, which adds SSL/TLS encryption to mitigate these risks. 6. Quick summary for troubleshooting. If you are troubleshooting a connection and can log in but cannot see the file directory, port 21 is working, but the data ports or passive mode settings are likely blocked by a firewall. How the SSH protocol works. The protocol operates in 3 distinct layers to ensure that data remains private and the identities of both the client and server are verified. Transport layer establishes the server's identity and sets up the encryption. It ensures that if data is intercepted, it cannot be read. User authentication layer verifies that the user has permission to access the server via passwords, SSH keys, or multi-factor authentication. Connection layer manages the actual communication channels after authentication is successful, allowing for multiple sessions like terminal shells and file transfers over a single encrypted connection. Key security features SSH replaced older protocols like Telnet and Relogen, which transmitted data, including passwords, in plain text. SSH provides encryption, uses algorithms like AES to scramble data. Data integrity uses hashing like HMAC to ensure that data hasn't been tampered with during transit. Authentication supports public key infrastructure, PKI. Instead of a password, you use a private key on your machine and a public key on the server. This is significantly more resistant to brute force attacks. 1. Introduction to RDP. Now we're moving on to the Remote Desktop Protocol, or RDP, which was developed by Microsoft. RDP is the standard for accessing another computer over a network using a graphical user interface, GUI. While protocols like SSH are text-based, RDP allows you to see the full desktop of the remote machine as if you were sitting right in front of it. 2. Port and protocol specifics. DP primarily operates on TCP port 3389, but it can also utilize UDP port 3389 for improved performance in high bandwidth scenarios. The connection manages the control commands, user input like mouse clicks and keystrokes, and the visual session management. 3. Resource redirection. One of the most powerful features of RDP is resource redirection. This allows the remote server to see and use your local hardware, such as your printer, clipboard, or even your local disk drives, making it easy to move data between the two systems. 4. Security risks and best practices. Because it provides such deep access, port 3389 is a massive target for attackers. It is frequently targeted for brute force attacks, where attackers try thousands of password combinations, and it's a common entry point for ransomware. To secure it, you should never leave port 3389 open to the public internet. Instead, always use a VPN to access the network first, and ensure network-level authentication, NLA, is enabled to require a login before the full desktop session even starts. 5. Comparison summary. Compared to FTP, which we just discussed, RDP is far more complex because it handles a live visual stream rather than just file packets. While RDP does include encryption, it requires much stricter access controls, like MFA and account lockout policies, than many other protocols due to the high level of control it grants. Speaker notes: Telnet, port 23.1. Introduction to Telnet. Moving on to port 23, we find Telnet. This is one of the oldest protocols in the book, designed back when the internet was a much smaller and more trusted place. Its purpose is to give you a remote command line interface to a device. 2. How it works. When you connect via port 23, you are establishing a virtual terminal session. Everything you type on your keyboard is sent to the remote server, and the server's output is sent back to your screen. It's simple, fast, and lightweight. 3. The major security risk. Here's the red flag for this slide. Telnet has zero encryption. It transmits every single byte in plain, readable text. If you log into a router using Telnet, an attacker on that same network can see your administrative password as clearly as if you had emailed it to them. 4. Modern usage. In a modern professional environment, you should almost never see Telnet in use on a production network. We have replaced it with SSH on port 22, which does everything Telnet does, but wraps it in a secure encrypted tunnel. Today, Telnet is mostly used for basic connectivity testing, checking if a port is open, or for accessing very old legacy hardware that doesn't support modern protocols. Think of network ports like the doors to a building, while some doors are hidden in the back. Ports 80 and 443 are the main front entrances of the Internet. Because every website needs them to stay open for public access, they are the most frequent targets for hackers constantly scanning the web for a way in. The unlocked door, Port 80, HTTP. Port 80 runs on HTTP, which is basically the old school way of sending data. The biggest problem here is that it sends everything in plain text. If you're sitting at a coffee shop on public Wi-Fi and log into a site using port 80, a hacker on that same network can sniff your traffic. They aren't just seeing that you're online. They can literally read your username and password as they travel through the air. This is a classic man-in-the-middle, MITM attack, where the hacker acts as a silent, invisible listener between you and the server. The false sense of security, port 443, HTTPS. Now, you've probably been told that port 443, HTTPS, is safe because it uses encryption. While it's definitely better, it isn't bulletproof. Clever attackers use techniques like SSL stripping or SSL hijacking. In these scenarios, they trick your browser into downgrading its security or redirecting you to a fake version of a site, like a banking portal, that looks perfectly legitimate. Even though you see a lock icon, the attacker could be intercepting that secure connection in the background to harvest your credentials.
Port 443 is the default port used for HTTPS, which is the secure version of web browsing. It protects data by encrypting communication between your browser and a website using TLS or SSL. This means that information like passwords, credit card numbers, and personal data cannot be easily intercepted or read by attackers. When you see the padlock icon in a browser or a website starting with HTTPS, it means your connection is going through port 443 and is secure. Port 80 is the default port used for HTTP, which is the original way websites communicate over the Internet. The major issue is that HTTP does not encrypt data, meaning everything sent, like usernames, passwords, and credit card information, can be viewed by attackers if intercepted. This makes port 80 highly vulnerable to attacks, such as man-in-the-middle attacks, where an attacker can listen to or modify communication between a user and a website. That's why most modern websites now redirect traffic from port 80 to port 443, which provides encryption and security. Let's talk about one of the most important but often invisible systems on the Internet, DNS, the Domain Name System. Think of DNS like the Internet's phone book. When you type google.com into your browser, your computer doesn't actually understand words. It needs a numerical IP address, like 142.250.190.14. DNS is the service that translates friendly domain names into those machine-readable IP addresses. This entire process happens in milliseconds, usually using port 53. Most DNS queries use UDP port 53 because it's fast and lightweight. If the response is very large, it can fall back to TCP port 53. Here how it works. When you make a request, your computer first asks a recursive resolver, usually operated by your ISP or companies like Google or Cloudflare. That resolver then checks with root servers, then top-level domain servers like .com or .org, and finally the authoritative name server that actually owns the domain. Once it finds the matching record, usually an A record for IP4 or AAAA for IP6, it sends the IP address back to your device. This hierarchical system is incredibly efficient and distributed, which is why the Internet can scale so well. However, DNS was not originally designed with security in mind. That's why we now have DNSSEC for validation, and why DNS over HTTPS, DOH, and DNS over TLS, DOT, are becoming more popular. They encrypt DNS queries so your ISP or attackers can't easily see which websites you're visiting. In short, every time you browse the web, DNS is working silently in the background to connect you to the right destination. Next, let's talk about file sharing and internal infrastructure ports, often called the service entrances of a company network. While ports like 443 and 53 face the internet, these ports usually operate inside the company network. They're the ones employees and systems use to share files, access servers, and move data between computers. The most common is SMB on port 445. SMB, Server Message Block, is what Windows uses for file and printer sharing. You'll also see NFS on port 2049 in Linux environments. These services are extremely useful, but they're also very dangerous if compromised. Why? Because they allow lateral movement. Imagine an attacker gets into one employee's laptop through phishing. Once inside, they can scan the network looking for open port 445 shares. If they find weak permissions or an unpatched server, they can jump from machine to machine, steal data, deploy ransomware, or quietly move toward high-value targets like domain controllers or file servers. This is exactly how many major breaches happen. The attacker doesn't break through the front door, they walk through internal doors that were left unlocked or poorly guarded. Other risky infrastructure ports in this category include RDP on 3389, which gives remote graphical control of computers, and older protocols like FTP on port 21. The key takeaway is this: internal file sharing and infrastructure services are necessary, but they create a hidden network of entrances inside your organization. If these are not properly segmented, monitored, and hardened, they become the perfect highway for attackers to move freely once they get past the perimeter. Port 445 is where SMB lives Server Message Block. This is the main protocol Windows uses for file and printer sharing across the network. It's incredibly useful in a company because it lets employees access shared folders and network drives easily. However, it's also one of the most dangerous ports internally. If an attacker compromises just one computer, they can scan the network for open SMB shares on port 445. With weak passwords, unpatched systems, or overly permissive shares, they can move laterally, jumping from one machine to another, escalating privileges, and eventually reaching servers that hold sensitive data. This is exactly how many ransomware attacks spread so quickly inside organizations. Best practice is to limit who can talk to whom over port 445, keep systems patched, and never expose SMB directly to the internet. Next, we have ports 137 to 139 NetBIOS. NetBIOS is a very old Windows networking protocol. It was originally designed to help computers find each other on a local network by translating computer names into IP addresses. It uses 3 ports. Port 137 UDP for name registration and resolution. Port 138 UDP for datagram services. Port 139 TCP for session services. Even though modern networks prefer DNS and SMB on port 445, many organizations still have NetBIOS enabled for backward compatibility. The big problem: NetBIOS is extremely chatty and insecure. It happily gives away information like computer names, workgroup names, and sometimes even user accounts. Attackers love it because it makes reconnaissance very easy. Once they know the names of machines and shares through NetBIOS, they can then target port 445 SMB for actual attacks and lateral movement. Best practice today is to disable NetBIOS on modern networks unless you have a very specific legacy requirement. Many security frameworks recommend blocking or disabling these ports internally to reduce the attack surface. Ports 161 and 162 are used by SNMP, Simple Network Management Protocol. SNMP is the main way network administrators monitor and manage routers, switches, firewalls, and other infrastructure devices. Port 161 is used for polling devices, while port 162 is used when devices send alerts called traps. The big security issue with SNMP is that older versions, V1 and V2C, rely on simple text passwords called community strings. The defaults are often public for read access and private for write access. Many organizations never change these. If an attacker gains access to SNMP, they can map your entire network topology, see device configurations, traffic statistics, and even change settings on routers or switches. This gives them massive visibility and control. In many breaches, attackers use SNMP during reconnaissance to understand the network layout before launching further attacks. Best practice today is to use SNMP version 3 with proper authentication and encryption, restrict SNMP access to only management servers, and block these ports from untrusted networks. Next, we have the most critical category, database and email services. I like to call them the vaults. These ports lead directly to the crown jewels of any organization: customer data, financial records, intellectual property, and internal communications. On the database side, we see ports like 1433 for Microsoft SQL, 3306 for MySQL, 5432 for PostgreSQL, and others. These contain the structured, high-value data attackers are looking for. On the email side, we have SMTP for sending mail, ports 25 and 587, and IMAP POP3 for reading mail. Email is especially dangerous because it often contains passwords, financial documents, and internal strategy. Unlike some other services, when attackers reach these ports, they're usually very close to success. A single compromised database or email account can lead to massive data breaches, ransomware deployment, or business email compromise attacks. These systems should be the most heavily protected, with strong authentication, network segmentation, encryption, and strict access controls. If these fall, the impact is usually severe. Ports 1433 and 3306 are the standard ports for the two most popular database systems, Microsoft SQL Server and MySQL. These are the vaults that hold the organization's most sensitive information: customer records, payment data, usernames, passwords, and intellectual property. Because they contain such high-value data, attackers actively scan the internet and internal networks, specifically looking for these open ports. Once they find one, they may attempt SQL injection, brute force credentials, or exploit weak configurations to extract data directly. Many major breaches start with a poorly secured database on one of these ports. In ransomware attacks, criminals often exfiltrate data from these databases before encrypting systems, giving them leverage for double extortion. These ports should never be exposed directly to the internet. They need strong authentication, network segmentation, regular patching, and monitoring for suspicious queries. Port 25 is used by SMTP, the Simple Mail Transfer Protocol. This is the standard way email servers send messages to each other across the internet. While essential for legitimate email, Port 25 is one of the most heavily abused ports online. Attackers love it because they can use poorly configured mail servers to send spam, phishing emails, or malware at massive scale. A common attack is turning your server into an open relay, meaning anyone on the internet can use your server to send emails while pretending to be from your organization. This leads to email spoofing, where attackers forge your company's domain. If your server gets used for spam, your domain and IP addresses quickly get blacklisted. This can disrupt legitimate email delivery for your entire organization and seriously damage your reputation. Modern best practices include using port 587 for authenticated email submission instead of 25, implementing strong SPF, DKIM, and DMARC records, and never exposing an open mail relay to the internet. 389 is used by LDAP, the Lightweight Directory Access Protocol. This is the protocol that powers directory services like Microsoft Active Directory. LDAP is where all your user accounts, passwords, or password hashes, security groups, and permissions live. It's essentially the central identity database for the organization. Because of this, LDAP is one of the highest value targets for attackers. If they can access or compromise LDAP, they gain the keys to the kingdom. They can enumerate all users and computers, steal credentials, escalate privileges, and move freely throughout the network. Many advanced attacks, such as Kerberoasting, pass the hash, and golden ticket attacks, directly target LDAP and Active Directory. Best practices include using LDAPS, port 636, with encryption, restricting LDAP access to only trusted systems, and applying strong monitoring for suspicious queries. Never expose LDAP directly to the internet.